puasa terus gitu ya.
Ya ini lagi winter juga Pak, lagi winter, lagi musim hujan, jadi lagi dingin.
Banyak makan ya, makan daging ya.
Iya, kebetulan istri warung Padang Pak.
Oh, gitu.
Buka di sana?
Ya, nggak resmi tapi di rumah aja bisnis di keluarga.
Artinya untuk komoditas kita lah ya.
Iya,
Betul.
Komoditas kita.
Paling dicari kalau nanti bapak-bapak nanti ke Adelaide, nanti yang dicari nanti warung Padang itu.
Iya.
Rebutan itu kalau masyarakat Indonesia.
Adelaide itu dari Sydney berapa jam flight ya, Pak Guntur?
Rasanya 1,5 atau 2 jam Pak.
Oh, deket ya.
Dekat. Kalau naik mobil itu 24 jam.
24 jam.
Jadi ada pepatah Pak Rektor, orang Padang itu nggak bisa lihat pojokan, jadi langsung gitu.
Iya. Langsung produktif ya?
Iya. Lihat
Ada
pojokan
space.
langsung ke rumah makan gitu ya Pak Guntur ya.
Betul. Kalau istilahnya dokter manajemen itu semuanya.
Iya.
Semuanya kalau orang Padang. Nengok aja peluang ada space, langsung manajemen.
Betul.
Langsung bisnis pikirannya.
Betul. Iya. Langsung
Ya,
produktif, pokoknya nggak ada istilah waktu siang, terus senggang.
Nggak ada. Kebetulan istri juga running private family daycare juga di sini Pak.
Oh, gitu ya.
Jadi istri ya di rumah aja, tapi orang ngantar anak-anak. Jadi istri nggak usah keluar, kita aja yang keluar, tapi ya istri dapat penghasilan gitu. Nah kan harus pakai gigi 2 sekarang, nggak boleh pakai gigi 1. Sarah.
Iya.
Pak Guntur?
Iya, siap.
Ya, biar nggak terlalu sore mungkin ya.
Baik Pak. Baik.
Mungkin mau berbuka juga Pak, di sini juga kita mau berbuka itu.
Iya.
Bicara juga. Nanti ngobrol-ngobrolnya insya Allah disambung lagi kapan-kapan.
Baik.
Pak Guntur ini tadi ya Pak. Jadi
Ya, silakan.
Kita mulai mungkin Pak. Mohon izin ya. Bu Dwi, silahkan.
Baik. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat siang, good afternoon. Okay, today we are from Faculty of Engineering, University of Pamulang, proudly present an open lecture and webinar on fundamental of system engineering. Today there will be 2 distinguished lecturers or speakers. The first is Dr. Guntur Tanjung from the University of Adelaide, South Australia. And the second is Professor Jung, Director of Technical Engineering Program, Kepco International Nuclear Graduate School, South Korea. Okay, we will not go long. We start shortly with some welcoming speech. Jadi ada welcome speech. Yang pertama adalah dari Kak Saiful. So, the first welcoming speech is from the Dean of Faculty of Engineering, University of Pamulang. We kindly invite Mr. Saiful Bahri, PhD, to deliver the speech, please.
Ya, baik. Terima kasih, Bu Dwi. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Salam sejahtera bagi kita semua. Distinguished Chairman of Sasmita Jaya Group Foundation, atau dalam bahasa Indonesia Yayasan Sasmita Jaya, Bapak Dr. Honoris Causa Bapak Dr. Andes Haji Darsono, Distinguished Chancellor of Pamulang University, Dr. Dayat Hidayat MM. Distinguished speakers, we have 2 speakers today. First is Dr. Guntur Tanjung. He is the Mechatronic Engineer, School of Agriculture, Food and Wine, the University of Adelaide, South Australia. And the second one, the speaker, Professor Jung Jae-Cheon, PhD, is the Director of Technical Engineer, King's University, South Korea. And also the excellencies, dear colleagues, ladies and gentlemen, lecturers and students. Thank you to each and every one of you here for being here, especially with us today. we are very pleased to be able to welcome all of you in the first open lecture and webinar of Faculty of Engineering, Pamulang University, today, 22nd of May, 2020. Before we get started, I would like to express my sincere appreciation to all of you here for generously help us to make this event come together to become a success. The purpose of this open lecture is to enhance and enrich as well our knowledge in the field of engineering, especially the fundamental of system engineering. As we know that the system engineering is so essential today as a robust approach to design, to create and operate a successful system, whatever the application today, either for chemical, mechanical, electrical, as well as for software engineering. And also I would like to report today that the registered participant actually is about 310, but unfortunately, it's not yet coming all of them. We'll wait. Will come in soon. And we are also very grateful today for the support of IT service, Mr. Pranoto, to stream and record this open lecture via YouTube. And everyone who's not able to come to this event, they can watch this event through the live streaming and YouTube later on. Therefore, again, I would like to welcome you all. And the participant mostly is lecture. It's about 55% is from Pamulang University, as well as other universities near of us here. And 30% students from electrical, from mechanical, industrial engineering, and informatics. The rest are from state-owned companies such as PLN, Indonesia Power, and from research institution as well, from Batam, LIPI, BPT, and other manufacturers. So again, we are very warm welcome to all of you here, everyone. Dalam kesempatan ini kami juga mohon perkenan Bapak Ketua Yayasan, Bapak Dr. Honoris Causa, Bapak Haji Darsono untuk memberikan arahan, memberikan sambutan kepada kami. Kami sangat menunggu-nunggu arahan dan sambutan dari Bapak. Kemudian juga kami mohon perkenan Bapak Rector untuk sekaligus menyambut dan membuka acara ini. Mudah-mudahan acara ini dapat berjalan dengan lancar dan we will have a fruitful discussion later on and more knowledgeable and better understanding after this event. That's all my speech. Thanks again for all of you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Pak Saiful, for the welcoming speech. And the next welcoming speech is from the Chairman of Sasmita Jaya Group Foundation, Bapak Ketua Yayasan. We kindly invite Dr. Darsono, please, to deliver the speech. Silakan Bapak Darsono untuk menyampaikan pidato pembukaan.
Terima kasih, Pak. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Yang kami hormati Pak Rektor dan jajaran Rektorat, Pak Saiful, sebagai Dekan Fakultas Teknik Universitas Pamulang. Yang kami hormati narasumber kita dari Australia, Pak Guntur, dan dari Korea. Kami ucapkan selamat ketemu, selamat kenal dengan Universitas Pamulang dan khususnya dengan saya secara pribadi. Kami atas nama Yayasan mengucapkan terima kasih kepada teman-teman Fakultas Teknik yang telah menjalankan agenda akademik, menyelenggarakan webinar dalam situasi yang masih prihatin di Indonesia. Tadi saya dengar obrolan kalau di Australia katanya kondisinya sudah normal, mudah-mudahan di Indonesia pun juga nanti tidak terlalu lama juga kembali ke kondisi yang normal. Karena kondisi saat ini betul-betul semuanya jadi macet kalau di Indonesia itu. Sehingga kita serba kesulitan. Nah, mudah-mudahan kondisi di Indonesia nanti cepat akan kembali seperti keadaan semula.
Amin.
Kami ucapkan terima kasih kepada teman-teman Fakultas Teknik yang mengumpulkan teman-teman melalui media, menyelenggarakan webinar ini untuk menambah wawasan, menjalin kerjasama dengan teman-teman di luar negeri, supaya kita bisa mengikuti kebaikan-kebaikan yang sudah ada, kemajuan-kemajuan yang sudah ada di luar negeri, untuk kita ikuti di Universitas Pamulang. Universitas Pamulang barangkali itu termasuk lembaga pendidikan baru kurang lebih 15 tahun kita berdiri, tetapi dari jumlah mahasiswa mungkin mengalahkan yang lain-lain, karena jumlah mahasiswa kita lebih dari 74.000. Barangkali jumlahnya cukup banyak. Tetapi dari sisi kualitas daripada lembaga kita masih jauh dari yang kita harapkan. Kita mempunyai angan-angan bukan saja besar dari jumlah, tetapi juga dari sisi kualitas, supaya kita bisa memberikan manfaat yang lebih baik kepada masyarakat kita. Nah, upaya ini adalah salah satu upaya kita untuk meningkatkan kualifikasi daripada lembaga kita, karena masyarakat kita selalu mencari perguruan tinggi yang baik dan terjangkau oleh kondisi ekonomi di Indonesia. Nah, mudah-mudahan apa yang kita lakukan ini menjadi kontribusi kepada bangsa dan negara. Kita bisa memberikan kesempatan pendidikan kepada masyarakat kita, terutama masyarakat yang kurang mampu. Nah, bagi Pak Guntur dan teman dari Korea, ini label kita itu adalah kampus yang terjangkau untuk semua lapisan masyarakat. Jadi kampus murah, Pak, ini, Pak. Nah, siapapun bisa kuliah di kita, dan mudah-mudahan dengan begitu kita bisa kontribusi terhadap kehidupan masyarakat kita yang masih tertinggal. Inilah niat kita. Nah, walaupun ini murah, tetapi kita akan berusaha untuk menyelenggarakan pendidikan sebaik-baiknya, dengan harapan masyarakat kita itu terbekali keterampilan yang cukup untuk perubahan kehidupannya. Atas nama yayasan, sekali lagi kami ucapkan terima kasih, dan mudah-mudahan ini bisa berjalan lancar dan memberikan manfaat bagi kita semuanya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you, Bapak Dr. Honoris Causa Darsono. And the final welcoming speech is from, we kindly invite the Chancellor of the University of Pamulang. Please, Dr. Dayat Hidayat, we kindly invite to deliver the welcoming speech. Please, Pak Rector.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Muhammadin wa alihi wa barik wasallim. Yang mulia dan dirahmati oleh Allah, Bapak Ketua Yayasan, para narasumber, Pak Guntur dan Prof. Jung dari Korea, rekan-rekan di Fakultas Teknik, Pak Dekan, Pak Kaparodi, dan semua para dosen, serta para peserta webinar yang turut hadir dan partisipasi dalam acara ini. Pertama, kami mengucapkan terima kasih kepada teman-teman yang telah berupaya melaksanakan ini sebagai pelaksanaan dari agenda akademik kita, bahwa Alhamdulillah Universitas Pamulang semua program studi menyelenggarakan agenda akademik yang boleh dikatakan hampir-hampir tidak terlalu banyak kendala, karena kita memang sudah terbiasa dengan perangkat untuk online, jadi sehingga Alhamdulillah bisa terlaksana dengan baik. Dan bersamaan dengan ini juga di sekretari kebetulan juga ada acara juga untuk acara kegiatan yang semacam ini. Jadi kita setiap hari, kemarin ada dua acara seminar, hari ini juga ada 2, dan terus bergulir setiap hari seperti itu. Oleh karena itu sekali lagi saya ucapkan terima kasih pada Pak Dekan sebagai pemerakarsa dan teman-teman prodi. Kemudian untuk teman-teman para dosen dan rekan-rekan semuanya, manfaatkan benar acara ini, kita coba mentransfer pengalaman-pengalaman di negeri orang. Pak Guntur tentu banyak pengalaman-pengalaman bagus untuk sharing, untuk berbagi dengan teman-teman di Indonesia. Kaitannya dengan, kami ada fakultas teknik, yaitu teknik untuk program studi teknik mesin, industri, elektro, kimia, dan informatika. Nah ini mungkin nanti Pak Guntur bisa berbagi untuk semua Pak dosen Fakultas Teknik ini, karena pada prinsip dasarnya tentu dari satu rumpun ilmu ini akan sangat bermanfaat dengan sharing yang ada. Kemudian juga kepada rekan-rekan sekalian, khususnya untuk Pak Dekan, ini harapannya nanti materi yang disampaikan oleh Pak Guntur dan Prof serta teman-teman dijadikan proceeding, Pak. Nanti teman-teman diminta untuk sambil berjalan mengumpulkan makalah, jadikan proceeding. Kita coba ajukan untuk ke berindeks lah, syukur kalau sampai tembus proceeding indeks Scopus. Saya yakin teman-teman kita, baik yang dari Batan, Puspitek, LIPI, PLN, kemudian dari internal kita, itu bisa dijadikan satu proceeding yang masuk ke kategori indeks Scopus. Dan kita sangat butuh sekali. Nah ini mungkin bisa ditunjang oleh makalah dari nanti Pak Guntur dan Prof. Ya. Jadi ini mohon Pak Dekan diorganisir, kemudian syukur kalau nanti teman-teman ada yang tembus dimasukkan ke dalam jurnal. Saya kira itu, dan dengan mengucap Bismillahirrahmanirrahim, webinar sore ini secara resmi saya nyatakan dibuka. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Thank you, Pak Rector, the Chancellor of Pamulang University. Ladies and gentlemen, this webinar will be conducted by Dr. Taswanda Taryo. Dr. Taswanda Taryo.
Yes, please.
Recently, he is a senior researcher at National Nuclear Energy Agency of Indonesia, or shortly we call Batan. And he is also lecturer at Magister Management at University of Pamulang, and also at ISTN. Dr. Taswanda Taryo graduated from Department of Physics, Bandung Institute of Technology, and then he got his Master of Engineering Science from Department of Chemical Engineering, University of Brunswick, Canada. And his doctorate is from Faculty of Mathematics and Natural Science, Gajah Mada State University, Yogyakarta. Formerly, he was Secretary General at Batan, and he was also the CEO of Project Management Office of Indonesian Experimental Power Reactor. We kindly invite Dr. Taswanda Taryo to conduct the lecture. Please.
Oke, terima kasih kepada Master Ceremony. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen, especially for the speaker from University of Adelaide, Dr. Guntur Tanjung, and also later probably there will be another speaker from Korea, Professor Dr. Jung. But before that, the first speaker will be delivered by Dr. Tanjung. So, and before presentation, I would like to read about the curriculum vitae of Dr. Tanjung, please. Yeah, Dr. Tanjung is the PhD from Mechatronic System and Maintenance Engineer. And also Dr. Tanjung is Manager Equipment Maintenance of Australian Plant. And he got the level 1 of the Certified Infrared Thermographer. And also he licensed also the remote drone pilot, member of Engineer Australia, employees of University of Adelaide, and last but not least, the president of Indonesian Islamic Society of South Adelaide. He got a PhD from the University of Adelaide. Before that, he got the master in engineering from Gajah Mada State University. And at the beginning, he got the bachelor for the Bachelor of Education, Electronic Engineering in Ikipadang. So, ladies and gentlemen, this is the time for Guntur Tanjung, and I think your presentation will be around 30 minutes. So, and after that, it will be followed by question and answer. And I would like to remind for the all participants, if you would like to deliver the question, please make a note. And after that, the question will be delivered to the presenter. Dr. Guntur Tanjung, please, your time.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. For the opening ceremony, I will use the Indonesian language, and then for the presentation, I will use the English. So I will mix it up, English and then Indonesian, because the point of the communication is everyone understand what I say. So I will start with the ceremony. Yang terhormat Bapak Dr. Darsono sebagai Ketua Yayasan Sasmita Jaya Group. Kemudian selanjutnya kepada Bapak Rector Pamulang, University Pamulang, Bapak Dr. Hidayat. Kemudian dan setara jajarannya, dan kemudian yang terakhir adalah Bapak Dekan Dr. Saiful Bakri sebagai Dekan. Beliau mengkontak saya beberapa hari yang lalu, hanya 2 hari yang lalu mungkin. Idenya hanya untuk sharing knowledge, hanya beberapa orang student mungkin dengan dosen dengan dia. Bayangan saya, oke, no problem. Ternyata ini jadinya go public sampai 200 orang gitu. So very interesting, but we have to move on because the idea is let me sharing my screen. Okay, let's start with I'm taking the title of this my presentation is the system engineering and the case studies, because is it okay if I continue? Is anyone see my windows?
No, I didn't see the presentation.
No one see?
No, I cannot see.
Marzuki?
So
Marzuki?
So no one see?
Not yet.
So someone will present it for me, or I will present it from my side. So which one is that?
So I think the committee will present about your presentation. Pak Saiful?
All right then.
Yes.
So
I
I will
think
wait then.
Pak Guntur, just wait. Probably the committee will presentation and just you read.
All
Pak
right.
Saiful? Yeah, please.
Okay, I will wait the presentation. So while we're waiting, Bapak Dr. Saiful is my sahabat, and then when he says something this is serious, meaning it's serious, so I take that serious. So that's why. All right then. So should I start? Pak Taryo, should I start? Everyone can see the presentation now?
Yeah, presentation is okay.
Pak Taryo, please.
Slideshow, please. I think everybody can see. So, Mr. Guntur, would you like to continue the presentation?
All right. So someone is going to run the presentation, yeah?
Yes.
Okay. All right. Can you start that? Can you start the slideshow, Mr. Majugi?
Yes, please. Yes, please. Yeah.
Okay, so the idea of this presentation is not about try to lecturing everyone. The idea is just try to share the knowledge I have and then the experience I get while I'm staying in Adelaide. So I pick it up. The title is the system engineering, and then case study. Where is the presentation again? All right.
Yeah.
Okay. Good job. Okay. Next slide.
Next slide.
Next slide, please.
Next slide, please.
Okay, we start with the motivations. So we know, everyone knows the event of Isra, believe. As a Muslim scholar,
Yes.
everyone knows the story of this. Why I'm interesting to bring this start. Wait for the next one. So this is Isra, meaning, Pasaibul, go back again. It's the night journey of our Prophet Sallallahu Alaihi Wasallam from the Makkah to Jerusalem. So that's happened in 1,450 years ago. That's from Saudi Arabia to Palestine by doing that with the buraq. And it happens quick. And then today flight duration is around 2 hours return. So one way is 1 hour. But if we come back again to 1,450 years ago, the people doesn't trust. No way people can traveling, because the normal time, according to the people knowledge in that time, he need one way is 1 month, and the technology is only the red camel. That's the fastest technology they can have, and then return again 1 month. So in total, it's supposed to be 2 months. But after 1,450 years, now we invent an aeroplane. So that's how things. So that's why I say there's an advance in science, but we always say technology, but we're missing one part, which is I put a question mark in there, and I want that as a puzzle, and I want someday someone will be asking me at the end of the presentation, what is the question mark? What's the missing part in there? We cannot have science and suddenly we have technology. We have something in there. That's why we're discussing that now. So we don't know. Currently, we have this technology. We don't know in the future, maybe in 40 years, if we're using a flight, the concurrence, the one speed, the speed is more than the sound. Maybe it's only less than 1 hour. But we wait for the technology. Okay, next presentation. Slide, please. Next presentation. Yep. So before we keep moving, we're going to discuss a little bit about theory. So we were talking about systems engineering. There are 2 terms in there. One they call system, another one called engineering. We discuss with the system first. So system here, according to this explanation, is only a combination of interacting element. The idea is an element interacting, organized to achieve one or more state purchase. The element include all hardware, software, equipment, facility, personnel, process, and procedure needed for this purpose. So to explain this system is quite simple. If you want to see a high complex system, you can see your own self. As a human being, we have 5 very sensory, very good story. Start with eyes for visible. We have a nose for smell. We have a mouth for taste, and then we have an ear for voice, and then we have skin for feeling. Inside that, we have a brain, go down to the lung, to the heart, and then we have liver, stomach, intestine, go down. Imagine if one part of our body fail. Just a simple one, kidney. The human being is going to be collapsed. That's how the system works. That's the interacting element. You cannot expecting one element doing the job. You need to be as a whole part. Where is my presentation again? Disappear. Number 3. This one simple systems. Number 3, keep going. And then another simple, very high complex system is, let's say we have a car. The car is another system, a complex system. And then the next one is your computer, or your mobile phone. So everything you are dealing with, there's a system. Home is a system. A university is a system. And then a government is a system. And then a country is a system. So it's all a combination of interacting elements. If one of the elements is not working, the system is going to collapse. Same like pretending our heart is not working, the person is going to collapse. So we need this. And then we back to the engineering. That's the second word in the engineering. So the basic word of the engineering coming from a Latin word, they call engineer. In English called design. So this is a verb. This is something we have to do. That's why they call it a process. A process of what? Applying current knowledge, just including math, science, material, any material we have, computer simulation, and then we have this, sometimes people miss. The next slide, please. Another one. So if we see this one here, we have math, science, computer simulation, hardware. They combine together to do the engineering part, because we are applying all of this technology, all of this idea to become a new technology. But people sometimes forget other two things. There are two other skills we need to be successful engineering. The one miss is the communication skill. That's the main issue right now. How are we going to communicate our idea if we don't have, if we have a gap of language, for example? That's a very simple part. So if an engineer, for example, English is a must for engineer. So if a student now learning engineering, remember English is a must now. Maybe 10 or 15 years ago, that's have to, but now it's a must, because we need to talk with anyone involved in this area. And the second one, the other skill we need, sometimes the engineers forget about, is a business skill. Because at the end of the day, this technology need to be sold. And then when you're investing this energy, you're investing a lot of money in that. You're expecting return. That's why you need to become a business model. So that's sometimes people forget about the two part of this. So in my term, if you are study engineering now, remember, improve your communication skill. Get more second, third language. I don't know, someday China is controlling the world, and then you need to learn the Chinese language too, to do a business with them. But so far, Westerns controlling the world. That's why we need the Indonesian, the English language. And to me, it's a must, not have to. And the business part. So that's why combination of these three, we have the advanced knowledge, and then we have engineering in between to make a new technology or system. Okay, the next slide. I'm out of time because I only have 30 minutes. And next one is, so what's the system engineering? Now we combine these two words. So system engineering is another word to saying engineer system. Meaning, if I say it's translated to Indonesian, they call it system yang direkayasa. So we need system, we need to rekayasa this, engineer this. That's the idea of them. So at the end, This is a combination of components that work in synergy to collectively perform a useful functions. So the functions is the system, but the word is synergy is the key. The synergy is the key. So what's the difference between synergy and analysis? That's the key in there. So synergy, you know, we have a lot of subsystem around. You need to make them together, work as a one to achieve the, pretending like a university. Student is part of the subsystem in the university. That's why not everyone become a rector, only one person, because he has the capability of synergy, make this become synergy, all of this, the lecture, the university, the budget, the yayasan, all of this become subsystem, and then make that become synergy to collectively perform a useful function. If there is no useful function, it's not a system. Every system they have a function for that. And the next one is there's a robust approach, and then interdisciplinary. Interdisciplinary, if I say that to Indonesian language, that's a gado-gado. Imagine gado-gado, even though I'm fasting now, my time is starving, but yeah, I have to keep going. This is interdisciplinary, meaning gado-gado, that there is no saying that, oh, I only know electric engineering. No, you cannot. I'm only know how to do software. No, I'm only mechanical engineering. No. In industry right now, you need to be sort of like everything. You need to work with anyone from another engineering skill, because that's how that works. To design, like the main term of the engineering, creation, you need to create and operate the system. So the three terms in here, design, creation, and then operation, that's the key things in there. So most of the time, the first step of the engineering process is start with the task definition. The idea is, what's the requirement? The idea is what you want, what you need. Sometimes we want only a normal telephone and SMS, but what we need is really just calling and SMS. But the problem is what we want the best mobile phone ever. So we need to know what's the requirement. And the next one is the conceptual stage. That's why when we start to research what alternative approach around. And then the next one is the design stage. That's why when we start to make the model of the system, and then we start to simulate them. And the next one is the implementation, is how to producing the system element. Start with the creating prototype, integrating component to create system. We need to test them. And the most important thing is we need to back to the customer. Is the system work to what you need? Most of the problem now in industrial point of view is they make the system, they make the technology, and after that, it's up to the people to accept it or not. No, it's not the way it is. Okay, next slide. So the impact is almost in everyday life. We almost live in the system engineering impact. We cannot run away from that. We can see that that's become a social driving force. That what happened now with us. Cannot imagine long time ago, like 20 years ago, we can do a video conference like this with 212 people can speak together, and that's for free. And it's quite fast. That's how we are now become online people now. And then that's become a integral part of the business cycle for economic growth. We cannot run away from the technology anymore. It's become a part of our life. And then we can see new machines, new industrial is always coming every day. And then the most important thing is this is for the national energy sustainability. We have natural resource, oil, and then we have sun power, electricity, nuclear power, and then we can see now every day we can see a new building, road, airport, seaport. This all a system engineering result. And then we can see now the quality of improving the public health, food production security, finance system stability. Is all about system engineering impact. So I'm just talking about system engineering as a whole here, not just particularly only for software engineering, only for mechanical engineering. No, this is the whole part of our life. Next. So now we go to the case studies. This is a very interesting part. We know what happened now in the world. We see the evolution of the telecommunication platform. Remember from 1G, now we're going to start 2020, what they call 5G. That's one of the example here. This is to say, how fast is the 5G? Remember when we want to download the Star Wars movie in depth and definition, and then the size is like a 4 GB. If we are using old technology 1G, we're going to need 4 months, 27 days. That's how long is it. We go jumping, maybe we still live now. I still live in the 19, like a 2G. Because I still have that mobile phone with me. And then it say like a 5 days, 13 hours. Now we're jumping straight away to the 5G technology. It needs only 1.5 seconds. That's how the evolution of the platform is telecommunication. And then we maybe still using the 4G. And then it's already fast enough. It's already 30 seconds. Next. So that's one thing we need to put in mind. The next one is, this is the next one. The impact of the 5G evolution. This is the one we're gonna, like in Australia, for example, since 2009, they already built what they call national broadband network to support this 5G. So all this copper line, they already replaced it with the fiber optic, because the 4G is using a light speed. So since 2009, so 11 years ago, Australia has been start to replacing all of this infrastructure, especially all the cable, the old cable from the copper, to become a optic fiber to support this 5G evolution. So what they call NBN, National Broadband Network. I don't know with the what happened with Indonesia, but if this 5G from 2020, they're going to use the technology, and then we don't have any lag anymore. Remember when we speak, sometimes we have lag, and then we so slow, or the video is too slow, or maybe now everyone can listen to my voice clearly without any lag. That's because of the technology we have now. Maybe we already close to 4G to almost transfer to 5G. And Indonesia maybe, I don't know if they still stick in the 3G or 4G. But what happened after 4G, we're going to have the telemedicine. We already have that in Australia now. And then everyone's now don't need to go to the doctor anymore. They just speak with us. And then what do you want, whatever, we don't need to. We already have the telemedicine sometimes here, and then autonomous vehicle. Even the latest car now, 2020, they already have this smart girl voice remind us to, oh, you should press the brake, whatever. It's already so intelligent now. And then the next one is the Internet of Things. That everything in our everyday life, it will connect to the internet. That's how, because of how fast is the broadband now. And then the next one is the autonomous drones. So don't surprise, soon enough, we will see the delivery come to the front of your house with the drones. Don't surprise. And then the industrial automation is going to be so quick. And then the next one is the virtual augmented reality. Everyone's going to put this big eyes, big Google in front, and then it's going to start, even for doctor, they're going to use this one technology for surgeons. They don't have to come to the hospital anymore. They can do it from home. Okay, next. Now we discuss about what happened in my workplace. We have this facility, what they call environment data measurement. We're using a wireless network system. It costs us like 30,000 Australian dollars, like 300 juta rupiah. So the idea of this technology is because we have a big facility, we want to, as a scientist, or because scientists need it, they want to measure every environment's data, lightning, humidity, temperature, in every point of the building, because we have like more than 50 greenhouse and then like a 4 smart house in our facility, because they are all facility research facility for the plant science. They want to know the environment's data of that. So we are using wireless network sensors. We have like a 24, like in this diagram saying that we have in total 24, and then we are using a national instruments technology, including the lab view from the national instruments, and then we can access that from around the world. And then we get this data in the TMS format, and then we can open that in Excel or any tool for presentation. So we have the detail of what happened in the building. So that's what all the science wants, all the data. And next. And then we have this new technology. This is the first in the world, combine two technology, what they call growth chamber and then drought spotter. It costs us like 1.5 million rupiah. This is two technology, like we say here in the picture. This is called growth chamber. The growth chamber is the chamber where we grow the plant. This is wheat plant. Then we can simulate the grow in there by giving, like you can say there on the top, we have a LED instead of a normal light. And then because the scientists find out that, hey, the suns, the plant really only using a tiny wavelength of the suns for plant growing. So they already simulate that one. That's why the plant can be so exciting in growing, because they get the particular light wavelength. And then we have the drought spotter here, the technology where we can measure exact water respiration from the plant. This is very tiny, like a 5 gram, 10 gram, but they can measuring that accurately. Next. And the next one is hyperspectral imaging system. It costs us almost 4 million rupiah, 4 million rupiah. So it looks like simple, but it's very complicated system, because when you see this there, the tiny camera down, that's the they call it FINA camera, visible near infrared camera, and the top one they call short wave infrared camera. So let's say our eyes can detect the wavelength from less than 400 to 700 nanometers. That's what we can see, but we can see the plant with the same green, but really the water contents between the leaf is different. This camera can see the difference between it, because they can detect the water content. So why they call that hyperspectral? That's because in English term, spectral means a ghost. So people say, I can see the ghost. That's because, and people say, I cannot see. That's because of our sense limited to see the frequency of this creature. But with this camera, they can extend the ability to detect this wavelength, and then you can see something in there. That's why it's so expensive. The big camera, the one on the top, it costs like a 1.5 million rupiah, only for one camera. And the system is automatically can do the scan up and down, and then we still can move that to the top for the top view. I cannot see that. And then we have the webcam in there, so we can check that from home, from anywhere in the world, if the system works. See, internet make that happens. Next. I only have a less. And then the next one is home smart. Home smart home. You can see that here from start, from the door lock is all smart. You just need to show your face to the door, and then he will open you because he recognize your face. Ah, this is the owner of the house. You don't need to lock it anymore. So you don't have to worry about you lose your key. Just need to your face to the camera, it will open you, and then you have the security system there to detect you and to record anything. And the most, all the smart air conditioning, smart lighting control, energy management, appliance control, smart thermostat to detect and smart bathroom, garage door opener, all possible now to be smart because of this 5G revolution. And the next one, I have another 1 minute. And the next one is the future smart city or suburban. So don't be surprised later on in the future, we're gonna have desa, but very smart desa. Because it's all smart. Smart parking, water quality, all smart. Smart energy, all smart. Water waste management, all smart. Because of this Internet of Things. And the next question is people is going to be smart? Because the technology is going to be smart. That's the next question now. Is people can follow this. So that's why the next slide, I have another 10 seconds. The highlight is, as engineers, first of all, we need to be sensitive with what happened in the society. What the society needs. We need to create solution for that. That's what the engineers doing. All right. And then and the next one is we need to flexible and up to date to the current development of the science and technology. You cannot saying that, oh, I only know electric science, or I only know mechanical engineering science. No, you cannot. You need to be flexible, and then you have to know what happened. That's why you need to do the research, do the reading, and the most important thing is that you need to be adaptive to any change. Otherwise, the technology will move forward, the society will move forward. If you cannot adaptive to any change, you will disappear from the competition. And the next one people sometimes forget is the last one, the social networking. We are doing the social distancing. I'm asking you to guys doing social networking. With what? With industrial and business society, because they know what the society needs. So maybe that's my presentation. I finish my 30 minutes, and then we go for a question and answer.
Oh, thank you very much for a very great presentation. Yeah. Okay. Thank you very much again for your great presentation. Before we coming to the question and answer session, I would like again to repeat your highlight that the energy system, this system engineering is very sensitive in society, that meaning that I have what I really want, and also flexible and up to date to the current technology, and very adaptive if there is any changes, so the system can match for that. And also for finally social networking in industry and business is very important. Well, ladies and gentlemen, please come forward for the questions answer session. Is there any? Yeah, okay. Okay. There is a question from Raffi Walyude.
Saya minta izin, saya berbuka sebentar.
Oh yeah, please. No problem.
Karena udah berbuka di sini.
Yeah, okay. Okay. Yeah, please. Yeah. Pak Guntur, there is a question. The internet work used to be a data cable, and how it can be wireless. Will the electricity in the future be a wireless system? Would you like to answer that question? You got it?
It's very smart
question. So the internet. Okay. Yeah. Network used to be a data cable, but it be wireless in the future. How the electricity? Yeah. Please answer.
Yes, there's another futurist idea, but we can charging now without plugging. So that's possible. Remember now our mobile phone used to put it on the cable. Now we can put it in the surface. Just a matter of time now. People will find the technology in the certain area that the electromagnetic can reach and translate the signal become a power. But that's possible, yes. Because don't imagine electric on the air and then it's gonna shock everyone. No, not that. That's the signal. They're gonna find some material to translate the signal to become electricity. It's like the way the sun we harvest. with the solar energy to become electricity. Long time ago, it's impossible. Now that's become possible. But yeah, if you're talking about the future question like that, that's possible. Yes.
Okay, thank you. Yeah, still I'm waiting for the following question. So probably I would like to ask you about regarding that you are from Indonesia, right? And you know exactly that the agriculture is very powerful in this country. So what do you think about what kind of the system engineering can be very good applied for agriculture in Indonesia? What do you think about it? I'm waiting for the following question. Please answer my question.
Yeah. So particularly in the pertanian, ya Pak ya?
Yeah.
Yeah, because I'm working
please.
in the plant science research facility. So I know the answer of that because we have a lot of researchers, plant researchers from Indonesia working, do the research in my office. So like for example, now they're concentrating more on the. So they were concentrating on the rice research now, because the problem with the Indonesian rice is they're close to the sea, most of the rice field. So they're looking for a seed which can survive for the salt tolerance. Yes. In terms of the system engineering, like I said before, system engineering is a broad view. Even the scientists from rice or the plant scientists, they're using the concept of system engineering as well.
Yeah. Okay, there is another question from the participant. Can you hear me? Yeah. The signal used in submarine is very secret. So what kind of the technology support the equipment? And also, sometimes we can make or develop technology now, but still sometimes don't have the tool to advocate to make it work. How about it? I mean, one question about the cable is very secret in the submarine, and the other thing is how about the relationship between technology, system engineering, and the legal aspect? Thank you.
Yes. So you mentioned about the submarine in Adelaide. We have that project currently now with a big with France, $1 billion agreement to make a submarine in Adelaide. Yes. And then the question is, if there is no tools to support it, that's why we need to innovate. So there is no saying that there is nothing. We need to create it. That's what the system engineering. If the knowledge is not supporting that first, that's why we stop. But if the science, the knowledge is there, for example, the hyperspec camera, people cannot sense beyond human being visible before. But now the science proved there is a material to sense that. When the knowledge is available, there's the engineering, the system engineering, try to create something, become a new technology. So that's the responsibility of the system engineers to create that tools to become available up to what the knowledge, the current knowledge in that time.
Yeah. Okay. Second question about the the advocate itself. I mean the legal. Usually the legal sometimes is come behind, right? So how to solve that kind of problem? You know, technology sometimes go faster, but the legal is something is behind. How to make it?
So we're talking about the law here.
Yeah. Yes. Advocate. How to advocate to make it work? See?
Yeah, same like.
So you understand what I'm talking about?
Yes. So same like this. The Australian government, before they lose a little bit restriction about the COVID-19 issue, about the social distancing. They already developed it. Application, what they call tracing. people applications, and there's a lot of people complaining about the privacy. And then but now, and then government only can promise that we will not share your private information to any company, just for us to use that for the tracing. Yes, sometimes the technology in there, but the law is coming slow. Sometimes the law need to
how to solve it,
what the technology is. Because creating that, creating the law, too many arguments.
Too many arguments. Many people, many arguments. So
yeah, too many arguments between the lawyer. I mean, one of the slow part is the lawmaker factory. It is so slow, while the technology moving so quick.
So that's finally, how the final solution? How the final solution for the law?
Like I said before, everything is going smart if the people is going smart too.
Yeah. Okay. Yeah.
They need to be flexible.
Okay. There's another question. Yeah, Dr. Guntur. Question is very simply, what do you think? Because you are Indonesian, right? When the smart city can be realized in Indonesia, what do you think?
What do you think? That's possible. That's why I was waiting. If the new Ibu Kota moving forward, I want to become a smart city.
Yeah,
that's possible.
Okay,
but
it's possible. But what?
We need the 4G platform get into Indonesia first. The government need to setting up all this fiber optic infrastructure first before this happen. If we still have a copper, it's gonna be still in the 3G technology.
Okay, good.
Yeah, that's possible. I want the new Kota. Hopefully, whoever the president is gonna be a smart city.
Yeah. Okay. There is another question. Another question is from. So I will read it. You have one of the slides show that there are 4 stages in engineering design. Conceptual design, and then also the implementation. Curious, you explained that the concern on customer was put in the implementation stage, where it should be in the earlier stage, concept or design. So the question is, for example, the position of the technical commercial study is in place, and the product can be estimated whether it will be. Just a minute. It will be profitable or not. Could you explain explain about this for the future? Can you get
so the first step is the first step is what they call requirement between wants and needs. That's the first one. The last one is still the same, customer acceptance. The customer requirement. Is the customer happy with the system? So it's mixed up from the beginning and at the end. All the process is all about what the customer needs. So it's there, yes. And what's the point of the question?
Well, the question is, so hence the product can be estimated whether it will be profitable or not. So how about the position of technology commercial study? I mean, the commercial study. You got the question, I guess.
Yes, all of this process is investment. The investment is always a risk.
Yeah.
When you put your money and then your thought and then your time in there, that's your investment, and then you get your result. That's why the first highlight I have is you need to be sensitive in the society needs.
Okay.
If the society wants that, it will profitable. Like for example, the latest technology now, everyone's really crazy about that in the world is what they call a super booster Wi-Fi. So we have the technology now. It can boost, amplify the quality of your Wi-Fi, and everyone is crazy about that. And then everyone buy that. That's number one now. A technology, everyone's crazy about it. So in terms of the what they call it, the poverty, if you make technology where people like it, it's gonna be problem. But if you don't know what the people want, and then you're just creating a technology, no one's gonna buy it. That's why I said the first one, you need to be sensitive with what the people want. Mute Pak, apanya? Mikrofonnya di mute. Pak Taryo, mikrofonnya di mute.
Yeah. There is another question. Can the technology of 5G adopt in Indonesia? What do you think about the new system engineering technology, especially internet technology for all implementation in Indonesia? Currently, internet is over there, but how about the 5G if installed here? So what do you think what happened then?
It will come, I believe, because this is around the world. It will come. You cannot say to technology no. Because everything like what happened with the COVID, everyone is using the online. If you still have a slow internet, still have a lag in your video, people is gonna start complaining. We want the new technology here. So that's what happened. So they force us. The technology gonna force us. The evolution of this platform is gonna force us to adaptive. So we cannot say that no. Otherwise, you stay behind. So it will come. This is gonna be around the world. It's a matter of if who's in charge in the government. If they look for the future, they will start thinking about that one. They will find some budget for them. It will come.
Yeah. I mean, like or dislike, we have to accept new technology, right?
Indeed.
Yeah. Okay. Yeah. I think the time is very close, more than 50 minutes. But I have a question for you, Dr.
Yes.
Guntur. So regarding about you are coming from the very good University of Adelaide, and also we are here in Pamulang University. What kind of the cooperation can be developed, such those two universities for the future? Because we have also engineering here, faculty and other thing that. What do you think? What kind of collaboration can be developed? Thank you.
Yes, I cannot promise, but I can find a right person to have a meeting with the right person from the Pamulang University to have a chat about what collaborations. Because it's not my capacity to make a deal. I'm just a normal lecturer in here, not the management of the university. But if someone interesting to make collaboration from the university, I can find someone to talk with. But that's possible because it's not the first time. We have IPB coming to make agreement with us, MOU with us. So it's not the first time. We got a lot, a big university coming, talk with the University of Adelaide to make agreement or memorandum of understanding about maybe sending a student or for 3 months, any, that's possible, yes.
Yes. Okay, that's, again, before I close this session, I would like to probably to get for your permission that probably many student or maybe a lecturer from here would like to communicate with you. Say, I think you are ready to answer such many questions regarding about your expertise. Is that correct? Yes.
Yes.
For example, next time we would like to play with you. Yes, right. Because you agree, you have a great presentation. I think probably people are still ashamed to deliver the question. Probably there will be a question related to your expertise and maybe directly to your email, right? Okay, you will accept that, right? Yeah.
Yep. Pak Saiful know my email.
Okay, yeah. Okay, Dr. Guntur, thank you very much for your great presentation. And I really hope I will see you again. And also thank you very much for the participation, for the question regarding anything. Again, thank you very much. And please make big applause for Dr. Guntur. Thank you very much.
Thank you, everyone. So I will off for a while because I need to
Yes.
Salat Maghrib and then have
Yes.
my dinner. And I will mute
thank
and
you.
then turn off my camera. Thank you very much for everyone. Assalamualaikum warahmatullahi.
Waalaikumsalam.
Waalaikumsalam. Ya, Pak Profesor Jun sudah siap?
Siap, Pak. Sudah siap.
Profesor Jun, good afternoon.
Good afternoon.
Oh, good afternoon. Yeah, okay. Okay. Good afternoon, Professor Jun. Yeah.
Yeah.
Professor Jun. I think in the 1 hour we will have the presentation. I think I'm very sure from the title it is very interesting. But please allow me to before we start the presentation, I would like to read and to inform the all participants regarding about the your CV. Currently, Professor Jun is Director of Digital Technology in King's. And also, he is also the Chief from King's Digital INC Institute. And also, he's Executive Vice President, Korea Council and System Engineering. And it's wonderful. He's a Chief Editor-in-Chief, Journal of Korean System Engineering Society, and also board member Korean Nuclear Society. And everybody can know that the Professor Jun is he got a PhD in nuclear and quantum engineering KAIST, and also he has ever been engineering group supervisor in and triple S also team leader for project development team in KAIRI. KAIRI, I mean the Korean Atomic Energy Research Institute. Is that correct? Yeah, Professor Jun.
Yes,
Yeah?
correct.
And also he is the NPP test engineer Korea Unit 3 and 4 Kepco. Kepco mean Korea Electric Power Company. Is that correct?
Great.
Yeah. Okay, Professor Jun, I will give you presentation for about something like 30-40 minutes or so. So and after that, please allow me to let the every participant deliver your question. Now your time for your presentation. Yeah, thank you.
Of course, I would like to keep.
Yeah, someone here will give the presentation, and you just mention about your slide one by one. Yeah, Pak Saiful, ready? Please.
Yep. Bentar.
Yes, please.
Yeah, I'll right connect it.
Okay, good. Yes, please, Professor
Good
Jun.
afternoon, everybody. I'm in Korea, in Seoul today. I would like to deliver a very small knowledge on me. It's about the fundamentals of systems engineering. Dr. Guntur introduced a nice presentation today about the fundamentals of systems engineering. But it is. I would like to share more about based on my experience, not only my professional expertise, but also my education and teaching students on systems engineering curriculum. Okay, next. Today, I would like to deliver and discuss about the following 5 sections. First thing, before we are talking about the systems engineering, we would like to know about the system and what's the system and what's the systems engineering and what is the effectiveness of systems engineering. And then I would like to move on to how systems engineering apply to the actual work. And probably you are interested in what kind of role will be given to the systems engineer. And based on the actual job position on systems engineering, I would like to share some real work with you. It's about the systems engineering. And finally, I would like to talk about why systems engineering curriculum is necessary to the 21st university. Next. Okay. What's the systems engineering? Firstly, should talk about the systems engineering concept, and the second one is the definition of the system. So then it's analytical representation of the system. First one is the configuration of the system, and then every man-made system has life cycle. Even nature system has its own life cycle as well. Very close. Yeah, next. Yes. I need my slide, please.
Yeah. Pak Saiful, please.
Okay, next. Okay, this diagram shows the concept of systems engineering. System can be denoted by type 3 sentence pattern. It has subjective, verb, and objective. From here, you can find the system has a system life cycle on your right side. And then system requires decision and system. Recall, this is the one of the representation of the system and systems engineering based on the type 3 sentence patterns. Okay. Next. And then, before we go further, I would like to define what's the system. System requires what? Requires a value, right? Therefore, system will add some value to the input, and it will be delivered to the users. And inside the system boundary, there are so many system elements. They are interacting together. Think about the car. Without only chassis frame, we cannot drive. But if you add the wheel and then engine, we are able to drive a car. This is an emergent property of our system. So system requires interaction between system elements. For example, if it is a nuclear power plant, then fuel would be the input, and then electricity is an output. In between, within the system boundary, boiler generates steam, and then steam drives turbine and generator. Then it is time to get electricity delivering to the household. So, what's the major option given to the system? It is specified output and then probability of success. And then we need user satisfaction through the system. This is the definition of a system. Yeah, now, next. So, once again, I would like to tell you about what the system performs. System must add value to the input in producing an output. So, in the course of producing an output, there are so many controls, stakeholders, give their needs and expectation to the system, and probably there is a role and regulations around the system. Meanwhile, in the bottom, there are 3 enablers, opportunities, threats, and physical constraints. So, our mission is to make an acceptable outcome from the system. Okay, now, Next. So, and then here is one referenceable standards about the system. It is ISO IEC 15288. It is talk about the system in terms of this standard. Systems are man-made, created, and utilized to provide the services in defined environment for the benefit of users and other stakeholders, where the users and other stakeholders are very important. And then, what's the configuration of the system? System may be one or more of the following elements to constitute. And the hardware, software, humans, even processes and procedures are becoming a system and facility and naturally occurring entities, just like water, organization, and minerals like, okay, down. So, but nowadays, we are dealing with the systems of systems or system of systems. For example, on your left top, you are able to look at the physical breakdown of the nuclear power plant, having many subsystems or plant, sub-plant of nuclear island to the turbine generator. For what? For generating the power. So that we can build those kind of plants, we need many different types of disciplines. Nuclear, electrical, INC-like. Therefore, I can say that, as the professor said already, previous presenters already mentioned about, it is a kind of interdisciplinary. Down. So I can say that systems engineering is necessary for developing the system of systems. Next. So the second topic is about what's the systems engineering? How can you define it, and how will we apply systems engineering to the real world? Down. Next. So the main objective of systems engineering is to enable the realization of successful systems, and then it is focused more on the defining customer needs and required functionality in the early in the development stage. Why? We need to reduce and minimize the cost and minimize and reduce the risk, and then reduce the schedule. This is the objective given to the system engineering. And then we have to consider the following complete programs on operation, cost and schedule, performance, even training. If it is a man-made, very complex system of systems, and it requires a very intensive training and support throughout the operational period. For example, once the nuclear power plant is built, then it will be operable more than 40 years. So throughout that period, we need to provide a training support and even test, so that we can optimize the performance. This is how we can come up with those kind of objective and then satisfy the customer utilities based on the systems engineering. So systems engineering integrates all the disciplines. As I mentioned about on the previous slide about the nuclear power plant business, it requires different types of disciplines. And then, moreover, we need specialty groups into a team performing system development. And then, so systems engineering considers quality product that meet the user needs. It is defined by INCOJE, International Systems Engineering Council. And then the best option is to meet the user need and their expectation. Next. So I would like to share some knowledge about the application area of systems engineering from the non-technical area, non-engineering area. Can you look at the cover page of the document? This is a report to the President Obama for better healthcare and low cost. And you have to keep in mind that they have a Secretariat of Systems Engineering already as a high-level government officer. And in short, we call it as Obamacare, right? But after Donald Trump, he abandoned it, and now, due to the coronavirus, they have a trouble on the medical care. Specifically, here is the mission. The statement shown on this simple document is about improving healthcare delivery to the persons outside of the traditional healthcare setting. So, but there are so many uncovered people by the medical insurance in USA. So Obama wanted to improve the healthcare delivery to the person who doesn't have a traditional healthcare setting. So for the purpose of developing this kind of non-technical, non-engineering side of the report, it requires interdisciplinary approach. For example, administrator, medical doctor, okay? And then the general healthcare and the steps are required to provide their specialty whenever they are developing this kind of documents based on what? Systems engineering. Okay, down. Okay. Do you like movie? And here is the snapshot on movie from movie founder. It's about the speedy system engineering. For what? For standardization of the system for producing McDonald's burger within 30 minutes. On your right side, there is someone who climbs up the ladder and orchestrate all the steps, possible steps. Inside a tennis court. And then they draw the line and circle inside the court for what? For developing the optimized and standardized system for producing burgers. So I was truly fascinated when I watched this video that how systems engineering works for developing this kind of non-technical process. It is quite important. And then just like a conductor in the orchestra, and he orchestrates his step and to develop a standardized system. And here is the mission and constraint to produce the burger within 30 seconds. And then I truly recommend you that to visit this website, YouTube, and then to experience the world of standardization for producing the hamburger using systems engineering. And they called it as a speedy system. Yeah, next. And then how? Probably you may raised us on a question about how systems engineering is applied to the real world. So, for the purpose of delivering and sharing some idea, I would like to talk about the effectiveness of the systems engineering first. And then, probably, there are some cases for preventing the system failure based on the configuration management and so on, using systems engineering approach. Yeah, next. So, as I mentioned previously, systems engineering has an effectiveness on saving cost around 25% if it is properly applied to the system development, as well as risk will be reduced and shorten the schedule. This is a benefit. So if we are correctly apply the systems engineering. So let's define system life cycle with 4 different process. The first one is concept and system design. As Professor Guntur said, okay, and then the very first process at the pace for developing the system is concept design, as well as system design. So if you focus and put more energy on this area, then you can save the cost, reduce the risk, and shorten the schedule. So based on the traditional development process, if you add more effort, energy on the concept and system design over 10%, and then we will reduce the detailed design architecture effort around 5%, and 20% for the implementation, and 10% for the test integration. So, and then, moreover, the risk will be reduced by time. How? If you try to concentrate on the concept design pace, then probably at the time the risk will be up and down, and there are so many fluctuations and trial and error throughout the concept design. However, after setting down our concept design, then we can say that remaining pace will decrease and reduce the risk drastically to compare with the traditional development process. Next. And so I can say that about using 4 different types of businesses. One is car, airplane business, ship, and plant. Plant is one of the most complex system. And then in terms of the production per project, car has some mega scale of production rate, while the plant, it is 1 or 2 units. For example, if it is a nuclear power plant project. As about unit cost will be increased exponentially. If it is complex system, and then technology level is required to the complex system. So we can get more effectiveness when we are applying systems engineering to the complex system, which is one of the man-made mega system ever done. So, and for your interesting, I would like to introduce one more example for operational acceptability using the Volkswagen Beetle development story. Probably the requirement and the needs were defined by Hitler before the World War II. And then one day he wrote something about his need on the tissue, like this. And then he gave it to Porsche, and Porsche ought to develop Volkswagen. And in this story tells you that Hitler came up with some very basic need and expectation for the Volkswagen Beetle. It shall be sedan. And then the capacity is carrying 5 family members, 2 adults, 3 kids. And then the speed is around 100 kilometers per hour. And then the cost is around 990 Deutschmark at the time. It is equivalent to the 31 weeks payment for the average British workers at the time. So he needs to have economics. It's about the Volkswagen Beetle now. So this is the first prototype of the Volkswagen Beetle. I'm familiar with this, and young generation likes this kind of car instead of the old man. So how Hitler specified the operational effectiveness or down? Next. So Hitler provides what? Need statement. I need a car that's having this kind of performance and function. And then Porsche should develop the specification. Then whenever the car is made and tested, and it is delivered to the Hitler there, and it is time to accept the Volkswagen Beetle by Hitler. How? Based on the operational need. What kind of it? Speed, right? Capacity, shape, economics, and then driving conditions. Yes, under the autobahn road. Okay, down. So, for the purpose of generating some artifact system based on the system.
Excuse me, Professor Jung. 10 more minutes, please. 10 more minutes, please. Thank you.
Okay, yes, I will expedite. So, we are requested to use the B model here, and then the Hitler provides a mission need statement to the Porsche, and then based on this one, there would be the actual implementation of a car, and through the verification and test, then it is time to be accepted by the Hitler. So we call it as a system verification, the stamp. So after delivery, acceptance, then there are 3 more phases. They are operation, maintenance, and even disposal, right? Every man-made system requires operation and maintenance. After that, it shall be disposed. So we can define the system having system life cycle like this. Get down. Next. This is another system life cycle, launching rocket to the moon. And then this is graphical implementation and the representation of the launching rocket. And then next. So NASA specified their project lifecycle process flow like this, that both flight and grounding systems. And it has 1, 2, 3, 4, 5, 6, 7 major processes, as well as it deals with 2 big processes and steps, technical and technical management. So don't forget that for generating the man-made system, we require the technical process as well as technical management process. Go down, next. And then another one is that are implemented to the nuclear power plant recently, specifically in Korea. And then we need to keep a balance between the design requirement, physical configuration, as well as facility information like this. So once the design is set up, and then the design requirement should be traced to the physical configuration. Of course, those physical configuration should be traced to the facility configuration information. And next. Look at this one. There is one significant failure case of discrepancy between system drawing and physical system after 30 years operation. Then there was undefined belts detected, but workers opened the belt immediately after. This is the rigid rod waste system, and then the workers have been exposed radiation as well as they have a combustion by the hot water, rigid rod waste. So if the drawing is properly managed and updated, then they can make it and prevent the system failure, and then there is no casualty probably. Okay, down. Next one is about the systems engineers. As down. This is the report from CNN. It's about the fast job growth potential of the systems engineering, and then it defines what kind of job is given to the systems engineer, and then how fast the job is growing inside this American society. Down. Okay, next. And then if you, the previous one, there I would like to mention about the 3 different types of the job opportunity. First one is from rocket market. It is aerospace and the military business, and then it requires many jobs described like this. Model-based systems engineering. It is one of the capability to be expected to the systems engineers. Down. Even Amazon. This is Amazon as a down. Okay. Next. Okay, Amazon defines the systems engineer job like this. Amazon is IT-based retailers, and then even though they need systems engineer responsible for the design, deployment, and operation of application of their own system. So this is the world of systems engineer. Next. And how much they are paid. Then if it is Google, and then the annual salary for the Google systems engineer, the average is around more than $70,000 US. So the top one, salaries in the American society and business. Down. Next. And then, but finally, I would like to tell you about the why systems engineering curriculum is necessary. Yeah, next. So why do we need to establish a systems engineering educational program? It is aiming at cultivating T-shaped engineer. T-shaped engineer can be defined by the T-shape of the as a model, as having one or two technical expertise, as well as he is able to communicate and with his members, as well as he are able to understand about the interfacing disciplines. Based on these specialties, he or she has to have some capability of system thinking, as well as competence of technical development and management skills. This is the expecting to the T-shaped engineer. Specifically, it is for the systems engineer. Yeah, next. So, actually, I learned several systems engineering curriculum in King's, my university, and then this is the focusing area statement of curriculum in King's. Clear definition of systems engineering, and then if it is system development will require systems approach. And moreover, as a man-made system requires model, therefore we are more emphasizing on the model-based systems engineering. Next. So why the need and then the needs for systems engineering education? What kind of capability is required to the systems engineering to come up with a system development capability? The knowledge on the processes of the system development and the management of manpower and technology. It is a vector sum, therefore it is not a scalar. This is the vector, as in one capability is behind the others. We cannot come up with the better system development capability. So they must be harmonized together for building a generalist who is able to collaborate with a specialist. This is the given mission to the systems engineer. Down. Yeah, next. Okay, next. I would like to skip this one. Yeah, next. Probably there are so many. Yeah, next. And next. Okay. So I would like, this is probably, there are two more slides. And then how and what kind of human resources should we nurture for smart business in upcoming era? In 1970s, we are depending on the manual processing like this, blueprint, and 92 up to now, we are using computer-based front-end engineering, for example, the CATIA like a 3D design model. But in the future, the trend will be changed to the paperless engineering and optimized virtual production like this, based on the 3D printing. Next, I will show you. This is the 3D printing output, developed by King's using 3D modeling. So firstly, we have to do a design using 2D sketch, and then we came up with a 3D design rendering like this. Then, using ANSYS code, we are analyzing the fatigue, stress, and the integrity of the system before it goes to the production. But even though this is not a it is a scaled down model using the plastic, but nowadays the metallized 3D printing is available, then we can make it soon. After that, don't forget that stimulation, verification and validation activity and quality test is needed before it goes to the users. So why do we nurture systems engineer? It is for preparing the upcoming 21st paperless virtual producing period. Okay, thank you for listening today, and it is all that I have today.
Yeah, thank you very much for your great presentation, Professor Jung. And I think before because the question already delivered by participants, so probably one of the things that you already presented is I would like to note that the system engineering is really paperless engineering, and also they can be optimized in virtual production. Number two, in very efficient, and also the technology level goes very fast. This is the characteristic of system engineering. Yeah, in my hand there are some questions, and I think I'm very sure that you are ready to answer my question. Number one from Mr. Alfano is this is about the nuclear power plant. When the first time of nuclear power plant in South Korea built, and also and after that, how many? This is the first question. Second question: is South Korea intend to invest nuclear power plant in Indonesia because Indonesia has enough uranium in Kalimantan? Third, so is there any competition of nuclear power plant between South Korea and North Korea? That's the question. Please answer the question.
Yeah,
it's a very good question, I guess.
Thank you.
It is the third question is politics. Yeah? Yes,
okay.
Please.
Yeah, first the nuclear power plant was built in the late of 1970. It was Turkey-based Westinghouse nuclear power plant. But several years ago, we stopped operation after 40 years of operation. And now we are building 2 more units, and then up to now we have around 29 units on the operation. But then actually when we came to agreement with the North for non-proliferation of the nuclear, and then not to develop the nuclear bomb in the North, then we promised them with American government to build a nuclear power plant in North Korea, simple area. It is as a North, and then but that project had been terminated due to the political issue. So and now there is no business relationship between North and South if it is a nuclear business. Is it enough?
I really hope Saudara Alfano will accept the answer. Okay, thank you. The following question is regarding about the how about the impact of can you hear me?
Yes, I can hear you.
Professor Jung?
Yes, I can hear you.
So impact revolution of the presence of quantum computers, QBIT, on the modern control engineering discipline. How about the impact revolution of the present quantum computer QBIT on the modern control engineering discipline? Please answer question.
Actually, I'm not good at explaining on this area because then actually I didn't think about the quantum the computer-based control. So, but my best knowledge, it is a future of the competition and the control. So because, and if you diversify the cyber key, and then we are able to provide encryption capability to the control. So nowadays, the great threat comes from the outside, is a cyber threat. That's right. Therefore, and I believe that by taking those kind of new technology, we're able to keep the cyber terror from the outside.
Okay. Yeah. Thank you. Yeah. Professor Jung, there is a question regarding about the waste disposal. Probably this gentleman question about the nuclear power plant. So it should be this is the cost component when you design in the early design of the system.
Yes.
So how about the relationship? Is there any cost reduction because of this what do you call this stage? For example, we early design and putting also a harbor design for waste disposals. So how do you answer this question?
Of course, we are experienced to design and engineering of the 41 nuclear power plant disposal throughout that project. Yeah, we are experienced some tedious problem due to the unplanned cases would be encountered whenever we are trying to dismantle and dispose the nuclear reactor and nuclear facility. So the best option is actually the nuclear power plant is one of the most costly facility to be dismantled. So due to the radioactive material and then the waste. So if we are preparing a very nice plan before we are building the plant and preparing the radio waste procedure and pass, and then to think about how can you dismantle the components and then the structure inside, then I believe not only the cost-effective method but also reduced the radiation exposure to the worker. So it is quite important. And then don't forget that those kind of concepts should be established during conceptual design phase rather than the implementation and construction.
That's right. Yeah, this is very clear. Okay, thank you. The following question is, but this is only a comment. So he really hope that someday there is a joint technology between South Korea and North Korea. Probably this is political question, yes? Okay. Yeah. Okay. Now this is another question. Yeah, a question. The application of system engineering is very broad, right? I mean, in any kind of fields. I mean, the family, education, and anything, many things. As a lecturer, because Mrs. Miranda is a lecturer, how is the best way to teach the student about system thinking? So you got the question? Yes.
So, firstly, as based on my experience, I can say
your
that
experience, probably you can tell how your experience.
For delivering the system thinking capability, it is quite related to the creativity, right? And that students should be able to understand about the nature of the system. What's the system first, and then as based on the methodology of adding value to the input, right? And then they may expect a certain kind of outcome can be gotten from the system, and then they have to specify the system boundary because we are dealing with the man-made system at this moment. So, firstly, we have to think about not only the performance, but also the function of the system, behavior, by interacting among the elements inside the system boundary. I believe that it is one of the critical issues to be delivered to the students when we are teaching the students about the systems engineering.
Yeah.
Yeah.
Okay. Yeah.
And
Thank you.
then second one, yeah, of course. And I would like to add one more thing. We call it
please.
as an emergent property from the system. So it means that the system, which doesn't show some characteristics, with a single element can provide emergent property after interacting with the other elements. Okay, students should keep their mind on this nature of interaction within the system. Thank you.
Yeah. Okay, thank you. Another question, Professor Jun. I think you are be patient to answer the question. Is very good. This is from the Kiswanta from Unpam as well. Professor Jung, please explain to me how patent legalization for paperless engineering. So you got the question?
Of course, yes. And
yeah, please.
Of course.
Please.
So actually, when I studied about the paperless engineering, and then now we are calling it as green engineering, concurrent engineering, or sometimes it is agile production. So for the purpose of supporting those kind of engineering, so based on the paperless, then we need to build the capability of handling the modeling, simulation, analysis, and then printing. So from the perspective of the faculty, that students, if he or she is able to handle the modeling, simulation capability, and handling of the software to support those kind of capability. And then more important is to do an analysis before it is implemented to the actual artifact. That's very important. And then this is the good preparation for delivering the paperless production and virtual production process.
Okay. Yeah, thank you. Probably I would like to inform as well the some 3 or 4 people is very honored. Thank you very much for the presentation, because you already explained to us about the innovation of technology. Another question. The question is, I haven't seen it, but I have a question for you. So what kind of the engineering, system engineering in your country, while now the technology is used for solving about the pandemic COVID-19 in your country? What kind of the system engineering? I think it's a very good question, probably. I really hope. Yes, please.
I'm not involving in the medical area for the pandemic, but I can say that inside King's, right, we are very careful against the pandemic as a coronavirus. So we are established the plan first, and then we analyzed the threat and not the opportunity and the negative impact by the pandemic. So this is documented, well delivered, documented, not to spread the pandemic among the society, as especially excluded Kings. So this is one of the example to introduce the system thinking and the systems approach against the pandemic crisis.
Yeah. Okay. Thank you. I haven't seen but the following question, and even though the time is still 5 more minutes, but probably probably this is one last question. So how about the possibility for the I think probably you can talk about it with the professor with Pak Saiful Bahri, the Dean of the Engineering. What kind of the collaboration can be made between King's and University of Pamulang, for example? Thank you.
At this moment, I would like to support for your curriculum establishment is about systems engineering first inside your disciplinary because it is critical to nurture system thinking capability among the students, and then where establish the process will guarantee the successful output. So the very first moment, I would like to support your program personally, and then it will be moved forward to the school-to-school collaboration. So, and then, of course, the Professor Saiful and I discussed about the collaboration already. So, and then I have no intention to say anything else about our experience on the systems engineering education. So, for this time, I would like to provide all our experience and share it, and that before you are establishing your own curriculum inside Pamulang.
Okay. Yeah. Thank you very much for the very clear information first about the great and excellent presentation. And the second thing, I'm on behalf of the University of Pamulang would like to thank you very much for the accepting and answering the many questions from the floor. And I haven't seen yet again the following question. So again, I would like to thank you very much for the presentation, great presentation, and I would like to close this session. And thank you very much for the all participants who is very active to deliver question. Thank you very much, Professor Jun. And please make big applause to Professor Jun.
Thank you. That's my pleasure.
Yeah, ladies and gentlemen, thank you very much for participation. This is the end of the my session as the moderator for the second speaker. And now time is delivered to the Master of Ceremony. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Pak Taryo. Thanks God we have successfully completed this interesting seminar. And we would like to thank to Professor Jung and also Dr. Guntur Tanjung. We are so honored to have you in this seminar. And we also convey our appreciation to all of the participants. And before the closing speech, I will remind to all participants to fill the list of participants. Tolong untuk mengisi list absen untuk para peserta. Okay. And kindly we invite the Dean of Faculty of Engineering, University of Pamulang to deliver the closing speech. Please, Mr. Saiful.
Yeah. Good afternoon, everybody. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
My voice will be clear right now compared with the opening speech from the previous ones. Sebelumnya mungkin dalam bahasa mengingatkan kembali pada teman-teman peserta untuk mengisi daftar kehadiran ya. For all participants, please fill up the list of attendance. Betul? Untuk keperluan certificate for your certificate, jangan salah juga namanya. Please put your name correctly over there. Jangan sampai salah nama, salah gelar dan seterusnya nanti sehingga membuat kesulitan bagi tim kami untuk menerbitkan sertifikat ataupun kalau ada yang salah nanti bolak-balik. Okay, first we have to apologize for all participants if there are any inconvenience during this seminar or during this webinar. We've seen many times some kind of technical view of you sending your presentation or sending something to be presented here without any permission, yeah? But that's fine. We can handle it right now. And secondly, I would like to appreciate to all the speakers today. First, Professor Jung, for your kindness, for your help, for your patience to answer all the questions here. And secondly, for Dr. Guntur Tanjung, for the collaboration and your patience as well, and for your help to deliver the seminar. And we are hoping that we can meet all of you to the next open lecture. I think after Idul Fitri, hopefully in the June, I think, with another topic, interesting topic, I think we'll show you, we'll present you, I think, with another aspect or another view of engineering as well. And by saying Alhamdulillahi Rabbil Alamin, praise to the Allah, I will officially close the webinar open lecture for fundamental of engineering this afternoon. Alhamdulillahi Rabbil Alamin. Yeah. And thanks again for Professor Jung, for your kindness over there. Dr. Guntur Tanjung, I'm not sure. He's still here, or I think it's enjoy his dinner, I think. Over there. Okay. Alhamdulillahi Rabbil Alamin. That's all my closing speech. Assalamualaikum warahmatullahi wabarakatuh. I will hand over to Ms.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Oke.
Silakan, Bu. Ya.
Kita tutup hari ini. Alhamdulillah kita sudah selesai. Materi akan dikirimkan nanti lewat link. Demikian juga absen, mohon untuk diisi untuk keperluan e-certificate. Mohon maaf atas segala kekurangan. Insya Allah next time it will be better. Oke Pak,
Thank
monggo
you.
ditutup.
Ya.
Yeah.
Terima kasih semuanya.
Yeah. Oke.
Ya, terima kasih Bapak-Bapak semuanya, teman-teman mahasiswa, selamat berbuka puasa, selamat dari Fakultas Fisik semuanya. Ya, selamat.
Terima kasih,
Mas Saiful,
Pak
saya mohon izin ya.
Terima kasih, terima
Mas
kasih.
Saiful, saya mohon izin live ya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Bismillah Pak, terima kasih ya Pak.
Ya.
Next time.
Pak Haji, terima kasih Pak Haji.
Pak, silakan kalau ada pertanyaan-pertanyaan ditulis ya. Terima kasih Pak Marzuki.
Sama-sama Pak, sama-sama. Terima kasih semuanya.
Terima kasih Bu Tika. Terima kasih Bu Fifit. Ya, makasih Pak.
Terima kasih Pak. Koneksinya terputus Bapak.
Maaf lahir batin.
Oke, terima kasih semuanya. Sukses. Selamat untuk semuanya Pak Dekan. Selamat.
Terima kasih.
Terima kasih Pak Rector. Mohon maaf lahir batin juga.
Ya, sekaligus. Minal aidin wal faidin. Semuanya teman-teman. Untuk orang tua kita, Pak Haji Taswanda, terima kasih.
Terima kasih Pak Haji. Terima kasih Pak Yayasan.
Iya, Pak. Sudah di-share semua ya, Pak? Mhm.